Hi everyone. So this is just a little bonus tutorial that I'm just going to give you, just talking about word clouds and how you can generate word clouds really easily using Python. Now, when we come on to talk about natural language processing in the course, you'll learn a lot about how to explore your text, how to extract information from free text, particularly things like named entities or the sentiment of a piece of text. And as part of that, word clouds can be really useful tools to visualize things. So it might be that you want to explore your text before you do any further analysis, just to get a sense about what some of the words are that are coming up more frequently. Or it might be that you use word clouds at the other end to generate visualize some of your output. So for example, when we show you named entity recognition, you're trying to pull out certain things, named entities that are being talked about, and you may want to visualize those named entities that are being talked about more. For example, that might be very interesting for what you're trying to achieve. So word clouds, I'm sure most of you are familiar with them, this idea that you can visualize your words within a piece of text and the words that are used more commonly appear larger, more prominent, can be really useful for this kind of stuff, but they can also be really useful in and of themselves too. So I'm just going to show you this little standalone brief tutorial on how you can generate word clouds really easily using Python. The first thing I'm going to do, you need to install a package called WordCloud. To do this, you just install that in the same way that you would for things like SymPy and Mesa using pip. So you simply use pip install WordCloud in the Anaconda command prompt, and that will install WordCloud for you. The first thing I need to do in my program here is to import some stuff. Now, basically, this program is going to just extract some words from a text file and generate a word cloud from it. So I'm just going to show you briefly the text file I'm using. So it's going to be this one here. All this is just a sample piece of data from the Internet Movie Database, which is, so it's basically a movie review, somebody's review of a movie, and we'll use this data in the sentiment analysis tutorial that you do later in the course to show you how you can determine whether reviews are positive or negative, etc. But just for now, I'm just going to use this as an example of a text file. Could be any text file that we can generate a word cloud from. So that's the file that we want to generate our word cloud on. So in the program, I'm going to import what I need. So the first thing I'm going to do is import some stuff from word cloud itself. So from word cloud, I'm going to import the word cloud class. And I'm also going to import stop words. Notice the block capitals here. That's very important. I'll come on to stop words in a moment, why they're important, why we need this. I'm also secondly going to import the string library. Now, the string library basically allows us to do some really useful stuff. It gives us extra functionality when it comes to dealing with strings that can be very useful whenever we're doing natural language processing stuff or when we're working with text in some way. And then the last thing I'm going to import is matplotlib.pyplot as PLT in the same way that you've seen this many times before. We're going to use that to generate our, or to visualize the word cloud, I should say. So the first thing I'm going to do here is just to basically open up the file and read in the content. So just reading in that text file in the same way you've seen before. So I'm using a with statement, and I've said with open, and then the file name word cloud example text.txt. I'm opening that as a read-only, in a read-only mode. I'm not going to write anything, I'm just reading from it, and I'm opening that with an alias of f. So f now refers to the file, and remember the advantage of using the with statement for file opening is that once you finish with the file, it will automatically close. So once everything in the block of code in the with statement has been done, then the file will automatically be closed by Python. So all we've got in this block of code is just one single command. Now, you haven't actually seen this, primarily because this isn't a command you'd use that often. The .read command on a file will basically just read in the entire text as a single string of text. in one go. So it reads the entire file all in one go. It's usually not that useful. Usually you don't want to do that, and you've already seen better examples of how you would read in data. But when you're doing natural language processing, sometimes that's exactly what you want to do. You want to read in the whole text file and then work with it. So that's what I'm doing here. So I'm reading in the full text file all as a single string, and that's going to be stored in this string variable here called full text. Here, what I'm going to do is I'm going to establish a set of stop words. Now, stop words are words such as the and those kind of connecting words that we're probably not very interested in for this kind of analysis, because actually it's not very useful for us probably to know that the word the or the word and is used a lot in a piece of text. These are common words that just that are linking that don't really have much meaning in themselves. So we can establish a set of stop words, and word cloud has this stop words feature that allows you to has common stop words stored so that we can exclude them from our analysis. So what we're doing here is we're casting stop words as a set, and then I'm storing it in this variable here, which is now a set called stop words, but in lowercase. So that now will store a list of stop words that we can get rid of later, and I'll show you how to do that. The advantage of doing it this way is that we may want to include stop words for something, so we can easily either include or exclude them. So we're not getting rid of them at this stage, but we're just keeping them in this stop word set so that we can refer to them later. So what I'm going to do now, I've got my full file read in as a string of text. The first thing I'm going to do is tokenize that text. And tokenizing is basically just a fancy way of saying split it up into individual components. So in this case, by default, it'll split it up into individual words. So we take that single string of text, and rather than having a single string representing the entire text file, we're going to split it up into individual words. And you can call the .split method on any string in Python, and that will automatically, by default, split your text op into tokens representing individual words. So let me just run this initial block of code first of all. So if I run that, saying file not found, let's try that again. Okay, how's that run? Okay, just 1 second. See what's going on here. Okay, so it looks like my working directory wasn't set correctly, so let's try running that again. There we go. So I've just run this block of text. I haven't run the block of code. I haven't run the rest of it yet. So what we can see here is that we've got a number of variables. We've got F, which was obviously the file that we referred to just as we opened it. We've got full text. So if we have a look at full text first. So that was the first thing we did. We just read the entire file into one single string of text. So you can see that that's what it's done here with line breaks and everything is in there. And then in stop words, this is the set of stop words that we've set up. So things like which isn't itself, these aren't particularly useful words for us, and these are word cloud gives these to us, so we can exclude those later. And then what we've done here, we've taken full text, this single string here, and we've tokenized it. So now tokens is a list of strings, and if we go into it, you can see it's a list of strings where each string represents a word within the text file. Now, what you can also see here is that as well as being words, some of the words have got punctuation on them. So this word here, films, got a full stop because that's the end of the sentence in the text. So it's kept that. Now, we probably don't want that. We probably want to remove punctuation. Whenever you're doing this kind of analysis, you tend to want to remove punctuation, except where you're doing things like named entity recognition, which we'll come on to, where sometimes the punctuation can be important. But generally speaking, we probably want to remove that from our text, so that we're just dealing with the words themselves. So we'll have a look at how we do that next. So the way in which we can approach this is by using something called a translation table. So basically what we can do is we can tell Python to take its known list of punctuation marks and then use that to translate sequences of characters that have into another sequence of characters, so that such that any punctuation marks are turned into none. In other words, they're removed. Now, Python has built into the string library, which we imported here, has a list of common punctuation marks. So if I were to type in my console window here, string.punctuation, you can see what it outputs is the list of punctuation marks. So we've got inverted commas, exclamation marks, brackets, all sorts. So all the common common punctuation marks there. So what we can do is we can first of all use a function of the string library, the string function str called make trans, which makes a translation table. Now, don't worry too much about this, but basically what this line of code, if I just zoom in a little bit, what this line of code is saying is make a translation table and ignore the first two arguments we passed in here. We've done that so that we can access a third argument. So if we call the make trans method, if we give it 3 arguments, then the third argument, anything that's put in there, it will put in the translation table that anything in here will need to be converted to none, to nothingness, basically. So that allows us to say, put punctuation marks in here. So from string.punctuation, which has this list of punctuation marks, if you see any of those characters, turn them into nothing, basically. And the first 2 arguments basically just allow us to have a third argument. So we just set up and basically an empty translation table and then tell it, except punctuation marks, which I want you to remove. So that we store in something called a translation table, and I've called mine punctuation mapping table. And then once I've got my punctuation mapping table, then basically I can go through each of my tokens in turn and translate them into tokens that don't have punctuation. So this list comprehension down here is doing exactly that. We use the translate function to apply a translation table. So .translate will do this, and we just simply pass in the translation table we're using, which is the one we set up here, which basically says get rid of punctuation marks. And I'm just using a list comprehension. Of course, you could use an expanded for loop for this, but just for simplicity, we're using a list comprehension. So what we're basically doing is saying for each token in tokens, which is our list of individual words, apply the translation table that we've set up here to that token. And in doing that, it'll, if there's no punctuation in the token, that's fine. But if there is punctuation, then it'll remove that punctuation symbol with nothing. And then once it's done that, it will store that newly translated list into this variable called tokens stripped of punctuation. So let me run that. Oh, no, sorry, I haven't set that as well. There we go. So now we can see, so if we have a look at the, well, if we just briefly look at the punctuation mapping table, so you can see it's set up as a dictionary. I won't go into details about that, but basically that's how it's set up for Python. But the key thing here is that we should now have a new list. So remember, tokens, our original list, where we tokenized, still had punctuation marks. Once we've applied the translation table to tokens, then we've stored it in this new list, tokens stripped to punctuation. So if I have a look at that, you see it's all the same words, but there's no punctuation mark. So before we had a full stop after films, we had an apostrophe here after trias, within trias. So there's all of the words are there, but they've been stripped to the punctuation, which is good. That's what we want. So now we've got a list of words from our text file that are stripped to punctuation. Another common thing we might want to do when we're cleaning up our data for textual analysis is convert everything to lowercase. And we usually want to do that because we don't want to count capitalized words differently. So if somebody writes the word hello at the start of a sentence, they'd use a capital letter usually. In the middle of a sentence, they might not use a capital letter. But in most cases where we're analyzing text, we want to treat them as the same thing. We don't want to treat them as separate words. And by default, any programming language such as Python will treat those things differently. They're different strings. One has a capital letter, the other doesn't. So we want to be able to treat them the same. So the easiest way to do that is just to convert everything to lowercase. So there's no issues of capitalization at all. There are built-in methods to allow us to do that really easily in Python. And one such method is the lower method, which you can apply to any string. So .lower will basically mean turn this string into lowercase, make sure it's all lowercase. And so what I'm doing down here is, again, just using a list comprehension. I'm going through each of the tokens in my token strict punctuation. So this list here, we've got a list of words but no punctuation. And for each of those, I'm going to convert them into lowercase. So for each token in the token strict punctuation, then apply lower to that token. And then the result of that list comprehension will be stored in a list I've called lower tokens. So let's just run that and see what happens. Oh, no, that's gone wrong. Click the wrong one. So now we've got a new list here called lower tokens. So again, we've got our same list of words, but we haven't got punctuation, and now we also haven't got any capital letters. So we can see there's no capitalization on any of the words. So that's good. That means that the word hello with a capital H and the word hello with a lowercase h would be counted in exactly the same way. So now we've cleaned up our text data, we need to put everything back into a single string of text so that we can generate our word cloud. So here I'm just going to do that just by using the join command, which is another method of strings, which basically allows us to assemble a single string from lots of little strings. So in this case, basically what I want to do is take my list of strings in lower tokens, i.e. my list of words that are all lowercase and have no punctuation, and join them all back together with spaces in between to make one big string. Okay, so I do that simply by using a space string here. So this is just a string with one character, an empty space, and then I'm going to apply the join method to that. So I say .join, and then the thing I want to join with this empty space is my list of lower tokens. So if I do that, it will then join all of those words in that list together with spaces, and then it'll store that in this string here called join string. So if I run that here, we can now see we've got join string as a string, and we're back into a single string just as we had at the start. But now we've got rid of all of the punctuation, and we've got rid of all capital letters. So now we're ready to generate a word cloud. And this is actually really easy. So all we need to do is to set up a new instance of the word cloud class. So remember, we imported that right back at the start here. So we're going to set up a new word cloud. I've just called mine rather unimaginatively a word cloud. And it's a word cloud. And I'm going to specify the width and height in pixels of that word cloud. I can specify all sorts of things. So I've specified a background color that I want the background color to be white, could be whatever you like. Here I specified my stop words. So there's a built-in functionality to say, are there any words you don't want to count? And here I'm saying yes, and I set them up here as my stop word set. So it will be expecting a setup here to deal with that, and we can just refer to that set we set up earlier. And then the other thing I'm going to specify is that I want the minimum font size to be size 10. So uncommon words should be no lower than size 10, which does mean that depending on the size of the cloud you create, certain words may be lost because you're saying don't go any lower than a size 10 font. If you remove that, you just have progressively smaller and smaller words so that it accommodates all words. So all we do is we create a new instance of that and then call the generate function of the word cloud. And we simply pass in here the string of text that we want to generate the word cloud from. So in this case, it's the join string, the string that we rejoin together with spaces, but without the punctuation and without capital letters. It's all lowercase. So we've set up a new word cloud with these attributes, and we're calling the generate function on that word cloud, and we're passing in the string that we want it to generate a word cloud on. all that's left to do, the word cloud is now generated in that single line of code. So all we then have to do is plot it. And we use matplotlib to plot it, and we use something called imshow in order to basically display a predefined image. So in this case, the word cloud. So I'm just going to set up the size of the figure here. I've just done a 30 by 40 size. I then want to turn my axes off, because we don't want axes on our word cloud, because they'll be meaningless. So we turn that off using this command. And then I can say plt.imshow to show a predefined image. And I'm going to pass in word cloud, which is the name of the word cloud I generated. And that will plot our word cloud. And then I'm also going to save it as well. So I'm just going to call the savefig function to save that in case I want it for later. And I'm just saving it as a PNG file there called word cloud. So let's run it. Let's see what happens. So if we push F5, set that off running. So this time it's going to do exactly what we did before, but it's also going to have generated a word cloud for us. So if we look in plots, which is where they're stored, we can see a word cloud has been generated. And in fact, if we go into the PNG, you'll probably see it a bit better. Let me open that. So that's the word cloud that's been saved. And you can see that more common words have appeared larger and more prominent in the text. So we can see film, train, time, rather, these all seem to be common words. Hitchcock's pretty common. These are common words within this particular review. Now, of course, that's just a single review. In reality, useful word clouds will be more useful when you're doing it on lots, big bulks of text to find out what are the common things that are being said. But this gives you an idea of how you can do this really easily on any text file that you want. And you can play around with this. You can change the size, you can change the color. So if I wanted a background color of blue, for example, I can run that again. And it will generate the same thing, a word cloud, but this time the background color will be blue. I might want to change my minimum font size to, let's try size 2. Let's see what happens with that. And I can run that again. And again, that will increase the number of words that are included. So if we go back into the word cloud PNG, you can see more words have been included. They're much smaller now as well. So you can really play around with stuff like this, but they're really handy for being able to, at a glance, get really nice visualizations of the common words within text. And I'm sure you have lots of data, text data, where this might be really useful. So have a go at applying a word cloud. Really easy. Most of the work is just tidying it up. So it's just a case of essentially splitting your text up into individual tokens, and then getting rid of the punctuation, making everything lowercase, then putting it back together again and feeding it into a word cloud. And this does all the magic for you in this single line of code. And we can just use matplotlib to display it for us. So have a play around with that. Hope you have some fun with that. If you have any questions, as ever, do let me know. But I hope you found that useful tutorial. And I look forward to talking to you more about natural language processing in the natural language processing modules, where we'll talk more extensively about some of the AI-based methods, including sentiment analysis, where we try and judge the sentiment of a piece of text, and also extracting extracting particular types of entity from our text. That's all for now. See you guys later. Bye-bye.